Module 2, Lesson 6, Basic Structure of an Atom. Building blocks of matter. In this lesson, we are going to study the structure of an atom, also known as the building blocks of matter. So what is matter? By now you should have a decent understanding that matter is defined as having both mass and volume, or in other words, anything that takes up space and also has a weight. So some examples can be pretty much anything. Humans, we have a mass and volume, water, air, paper, you name it. Anything you can see, touch, has mass, volume, is made of matter. Now, what's a force? A force can be defined as an interaction between two bodies or two objects. There are different types of forces. A force is not made of atoms. Therefore, it does not have mass or volume. So, let me ask you, is a force matter? No, forces are not a form of matter. Forces of the atom include gravity, weak force, electromagnetic force, and strong force. Parts of an atom. The smallest possible unit into which matter can be divided is called the atom. The atom still maintains the properties of the element. It's made of protons, which have a positive charge, neutrons, which have a neutral charge, electrons, which are negative. Protons. Positively charged particles. They're located inside the nucleus. Every element has a different number of protons. That's what gives it its individual characteristics. The number of protons in an element is its atomic number. So recall from Module 1, Lesson 5, when we looked at the symbols in the periodic table, the atomic number was always in the square with the element. Protons contribute to the atomic mass of an element. And again, we see that on the periodic table. In a neutral atom, the number of electrons equal the number of protons. Electrons. Negatively charged particles. They're found outside the nucleus of an atom in the electron orbit or electron level. Each orbit can hold a maximum number of electrons. The very first shell can only hold two. The second shell can only hold a maximum of 8 electrons. The third shell can hold a maximum of 18. Once these shells are filled, electrons must move to a further out orbital. Electrons move so rapidly around the nucleus that they create an electron cloud. Mass is insignificant when compared to protons and neutrons. We call electrons fluff. Now, in a neutral atom, meaning the charges are the same, the number of protons and electrons are equal. Electrons are involved in the formation of chemical bonds. Neutrons. Neutrons are neutral particles, which means they have no electric charge. They help make up the nucleus of the atom. They contribute to the atomic mass. The same elements with different number of neutrons are called isotopes. Because neutrons do not have a charge, you may find some elements that have neutrons of different numbers. And those different numbered neutrons in those elements are called isotopes of that element. The atom's center. Protons and neutrons are grouped together to form the center or nucleus of an atom. Notice that the electrons are not part of the nucleus. So what makes up the protons and neutrons? Well, protons and neutrons are made of smaller particles. These particles are called quarks. Let's take a closer look at this neutron. Notice the smallest particles that make up this neutron? They have 2 orange and 1 blue. Altogether, there are 3. Now let's take a look at this proton. Notice the smallest particles again? This time there's 1 orange and 2 blue for a total of 3. So what do you notice about the number of quarks in the neutron and proton? Well, you can see right here, they both equal 3. So the mass of the atom, as we mentioned before, is derived from the protons and neutrons. So let's see how that works. A neutron weighs 1.67 to the power of negative 27, where the proton weighs 1.67 times 10 to the power of negative 27. And look at this electron here. It's actually to the power of negative 31. So that's 4 decimal places moved over, recall from lesson 2. So if we were to put neutrons and electrons on a scale, we'd have to put about 1,839 electrons to equal just 1 neutron. And then if we were to do the same thing with the proton, we'd need just shy of the number you'd need for a neutron. You'd need 1,836 electrons. So how do you think the mass of a neutron compares to that of a proton? Well, using this for a clue and this for a clue, it's safe to say that protons and neutrons are approximately the same mass, with neutrons being a smidge heavier. So the mass number, this is the total number of protons and neutrons in an atom's nucleus. We express it in AMUs, atomic mass units. Each proton or neutron has a mass of 1 AMU. What would be the mass number of this atom? Well, we've got 3 protons, 4 neutrons, for a total of 7 AMU. Now note, we didn't account for the electrons here. They're not heavy enough. They're insignificant to contribute to the mass, so it's just the protons and the neutrons. Atomic number. The number of protons in the nucleus of an atom is the atomic number. What would be the atomic number of this atom? 1, 2, 3. 3 protons. This is a representation of lithium, atomic number 3. No 2 elements have the same number of protons. The protons give the element its identity. Forces in an atom. Gravitational force. This is the force of attraction of objects due to their masses. The amount of gravity between objects depends on their masses and the distance between them. So just like our sun and our moon, there's a gravitational force because they are such massive objects. Now, to think of the atom, not quite the same scale, however, there is still a bit of a gravitational force within the atom. Another force is the electromagnetic force. This is the force that results from the repulsion of like charges and the attraction of opposite charges. This force holds the electrons, which are negative, around the nucleus, which has positive protons. So, just a quick refresher here. If you have 2 charges of the same, they repel. So those 2 positives repel, these 2 negatives repel. However, if you have opposite charges, they are attracted to one another, just like in the atom. Strong force. This is another force in the atom that holds the atomic nucleus together. The force that counteracts the electromagnetic force. So within the nucleus, the protons all have the same charge and they're being pulled apart from each other. They're repelling from each other due to the electromagnetic force. However, there is a strong force around these protons that holds them together. Weak force. This force plays a key role in the possible change of subatomic particles. So, for example, a neutron can change into a proton and an electron. This force is responsible for radioactive decay. So, I would like to thank Mr. Jones for the use of his PowerPoint. It was slightly adapted from his, but most of the animation and the content was from his PowerPoint, The Building Blocks of Matter. There are lots of great material on this site if anyone's interested in checking it out. Thank you for watching.